Hello students, welcome to the video class for the subject Power Electronics and PLC. So this video is for 5th semester Electrical and Electronics Diploma Engineering students. So today we will cover about the speed control of DC shunt motor using chopper. So in the previous video I already told you about the different factors which affect the speed of DC motor. And here today we will study the speed control of DC shunt motor by using chopper. So let's begin. So see, here it is your chopper. This circuit is the chopper circuit. This is the chopper switch. This is the DC shunt motor. Okay, so this is the chopper circuit and this is the DC shunt motor. So in this chopper circuit, what you get in the output side, you get what is the main function of the chopper. It converts fixed DC voltage to variable DC voltage. So in the output side we get variable DC voltage. Okay, so this variable DC voltage is the input for this DC shunt motor. Okay, so in this circuit there is one inductor. This inductor is connected here. Why this inductor is connected here? Because this inductor allows pure DC to this motor. Okay, because whatever DC we get here as an output of this chopper circuit, this is a variable DC and it has some pulsating portions. That's why this L inductor allow pure DC. Okay, so it blocks whatever AC part is there in this output side DC. And this inductor also stores energy. Okay, and it gives continuous input service to this DC shunt motor. Okay, so in this DC shunt motor, this is your armature winding, this is your field winding. Okay, so this is here, it is the waveform. So it is the DC input is this much and this is the output. We have output voltage like this. Okay, this is the output of the chopper circuit and this is the current waveform. Okay, this is the output current waveform like this. See here, here I1, this is the I1, this is I1 and this is I2. Okay, so I1 is the main level current. Mean level current means minimum level of current, and I2 is the maximum level of current. T on is the on period. This is here T on. Then this is the on period of the chopper circuit. T off is the off period of the chopper circuit. So when the chopper is on condition by applying gate pulse. Okay, so see here, chopper circuit is mainly consist of it is the combination of SCRs or BJT, power BJT or power MOSFET or IGBTs or GTOs, etc. Okay, so see here our main focus is in SCR part. So here we assume that SCRs are inside this chopper. So here SCR is commuted by the force commutation method. Okay, so see, when the chopper is on condition by applying gate pulse, if the chopper circuit contain SCR, then to turn on this chopper we need to give gate pulse. So then the path of the current is VDC plus chopper, L DC motor VDC minus. Okay, so this is the path when this circuit is on. Okay, this is the path. Okay, so at that time the free wheel diode is reverse biased, so that the free wheel diode is off. So and hence the inductor which is connected to DC shunt motor getting store energy with left side is positive terminal and right side is negative terminal. See, in this inductor it is positive and it is negative. So after chopper is off by force commutation method, so that the source is disconnected from the load, So at that time the energy is released from series inductor by changing its terminals. That means like this. See, this is the inductor is like this inductor. So initially it is positive and it is negative, but when chopper is off it is negative and it is positive. So uh, by changing the its terminals, what happens? So when chopper is off, energy is released from series. This inductor will release energy. So how it release energy? By changing its terminals, okay, through DC motor and free wheel diode. So it's like this. So now it is positive and it is negative. So the free wheel diode is forward biased. So like this current will flow. Okay, clearly understood? So the speed of the DC sound motor is controlled by controlling the on off time of the chopper circuit. So according to on and off of the chopper circuit, the required amount of supply is given to the DC sound motor and hence the speed is controlled. Okay, so whatever supply is given to the DC shunt motor, according to that speed of the DC shunt motor is controlled. Okay, so clearly understood about the speed control of DC shunt motor using chopper. So the next part is the list of the factors affecting speed of AC motor. So what are the factors which affect the speed of AC motor? So AC motor means normally you know the, induction motor or synchronous motor and synchronous motor. So induction motor has a variable speed, and in synchronous motor has the constant speed, that is synchronous speed. So for induction motor, the speed of an induction motor is given by Nr is equal to 1 minus S into Ns, and Ns is equal to 120 F by P. So here Nr is equal to 1 minus S into 120 F by P. This Ns part is applied here. So this is the Nr. From this equation we can vary the speed of an induction motor by varying frequency. This F is the frequency and number of pole. This P is the number of pole of an induction motor, and another so many methods are also present to control the speed of induction motors. Such methods are given by this is the pole changing method, stator voltage control method, supply frequency control method, rotor resistance control method, energy recovery control method. Okay, so but from the above method, from all these methods, there are two methods like frequency control and voltage control method. This is frequency control and voltage control method are generally used. Okay, so for synchronous motor, next come to synchronous motor. So for synchronous motor, Ns is equal to 120 F by P, simply because here speed is our constant synchronous speed. So common method to control the speed of the synchronous motor is supply frequency control, because here frequency is also there, pole is also there. So common method is supply frequency control method. Okay, so now we will study about the speed control of induction motor by using AC voltage controller. Now we will study this one. So come to this part now. See, this is the circuit diagram for speed control of induction motor by using AC voltage regulator. See, I will notify this part R as R, then this is Y and this is B, so that you can clearly understand. Okay, because ABC is also used inside this circuit. Okay, so this is RYB, this is ABC, this is C dash A dash, and this is your induction motor is connected over here. Okay, so see, first of all we will study about the different stages of operation of an induction motor. So here 4-quadrant operation with plugging is obtained by using of the circuit given above. So thyristor pairs, this is A, this is B, this is C. A, B, C provide operation in quadrant 1 and 4. 1 and 4 means here the pair C, here the pair A, so see here 4 quadrant operation with plugging is obtained by using of the circuit given above. This is the circuit. So thyristor pair ABC provide operation in quadrant 1 and 4. This is quadrant 1 and this is quadrant 4. Okay. And whereas A dash B C dash, okay, A dash B C dash means it is like A dash and B, sorry, A dash B C dash, A dash B C dash. Okay, so A dash B C dash thyristor pair, this is A dash and this is B and this is C dash. Thyristor pairs provide operation in quadrant 2 and 3. Okay, so while changing from one set of thyristor pair to another, that is from ABC to A dash B C dash and vice versa, there should be taken to ensure that the incoming pair is activated only after the outgoing pair is fully turned off. Okay, so see how it operates. Okay, so see here it is A, B, C is operated like this. It is in one quadrant it is operated in motoring mode. In the 4 quadrant it is operated in plugging mode. How? See, I draw over here. So see, let's RYB supplies like this. So we go in clockwise direction, R to Y, Y to B, then B to R. This is your motoring mode. So C, R, Y, B. So here A, B, C sequence. So when terminal is changed, any two terminal is changed, that means here I changed R and Y. So R is here and Y is here. So when terminal, any two terminal is changed, then the sequence becomes RYB. It is in anti-clockwise direction. So this is your plugging mode and this is your motoring mode. So in quadrant 1 it operates in motoring mode. Okay, so in motoring mode means this axis is your time axis and this is your torque axis. Okay, this is your torque, capital T, torque axis. So here our in motoring mode, here our torque is at this point torque is maximum, then gradually torque will decrease. At this point torque is 0, and when after this, when terminal change, then plugging mode is started. So here see again, here torque is reduced, gradually reduced to 0, and then here again torque is increased up to this point. So here if your motor rotate in clockwise direction, then motor reduce to reduce to the zero level speed, and then again gain speed in reverse direction. This is the plugging mode. So in the same way, here also it is a motoring mode, and here also it is a plugging mode. So here if your motor rotate in one direction, that means let's see in a clockwise direction, then after reaching this point the torque reduces to zero level, and then again torque will starts to increase in the plugging mode, and here the motor will rotate in the reverse direction of this quadrant 3 direction. So here it is motoring and it is plugging, then after plugging again it is motoring, then it is plugging, then motoring, then plugging. This sequence will go on. Okay, so in this way motoring plugging mode is appear in the different quadrants, and in these quadrants our speed of the induction motor will be varied. It, like in motoring mode, if it rotate in one direction and its speed is in one form, its torque is in one level, then again it is decreasing to zero level, and then again it is increasing to the next level of speed or torque in the reverse direction. That is the plugging mode. So in this way induction motor will run in the motoring or plugging mode in the various applications. Okay, in this way we can vary the speed of induction motor. So while changing from one set of thyristor pair to another, that is from ABC to A dash B C dash and vice versa, care should be taken to ensure that the incoming pair is activated only after the outgoing pair is fully turned off. So some disadvantages are also there. What? The first one is the output voltage depends upon both delay angle and period of the current flow. Okay, so which are dictated by load power factor. That's why if load changes, then the output voltage of the controller changes continuously. So and second one is the due to due to fluctuating the voltage and current, then the harmonics are present which may cause eddy current in the core, which causes the overheat of the induction motor. So these two are the disadvantages of the speed control of the induction motor. Okay, so with this we will conclude how we control the speed of induction motor by using AC voltage regulator. Okay, thank you.